Yeah, I was talking about the convergence test for E-cut wave functions. We want that there should be a value of E-cut wave function uh, after which the total energy does not depend upon the wave function, so that our subsequent calculation could not be affected by the size of
Okay.
plane wave basis.
Okay. So, brother, I have a question.
Yes.
Okay. So, if I understand this E-court during that time that we did PWTK, I think it handled this job better than this Foley manual method of E-court because you will just set the ranges you want. Am I right?
Yes, we will, when we want to make convergence test without some handling procedure, we have to change manually each time the value of E-cut wave function, and then
Okay.
corresponding to each value of E-cut wave function, uh, uh, we have to save output file,
Okay.
and also we uh, have to total energy have to uh, this is the total energy.
Yes.
So for each
When
E-cut
the
value,
E-court was 15.
yes, for each E-cut value, we must know the total energy. Let me say we should seek for total energy uh, final. Call. Okay, this is the total energy. And in other
Okay.
words, you can find if you will, if this will go direct to the total energy.
Okay.
This is the total energy of the
Okay.
system. We have to manually uh, uh, note this total energy and as well as value of E cut wave function.
Yes.
And that you
Okay.
should do
When
two or five or six or seven or eight or nine or ten different
yes. Yes.
calculations.
So if I recall for PWTK, we just set you use sec you use the sec command code 15 to like 30. It
Yes.
will run the iterations for you. Yes. Okay. Mashallah, for understand.
For that, I copy this. I will make here new folder so that it would not make some sort of, suppose I now name it cut scan. I paste it. Now I have to change it according to my needs.
Okay.
What is my need? First need is that I would like, uh, I should
Mm,
tell the PWTK that what is the input file with the help of
okay.
which to do the calculation. So this is the path of the input file. For the present case, the path of the input file is
The
this.
silicon.
This is in silicon folder, and the file is scf.in. But when I see that this is the directory, ecut scan, and
Okay.
this is the file. So this dot mean parent directory, and this means this is the file name. So for the present
Okay.
case, it is according to our needs. I selected the input path of input file from which it will load the input file. And after that, I consider a sequence. Sequence start from 12 with the step of 4, it goes to up to 40.
40.
And this scan per command is actually command from PCL language, which is recognized by the ECUT PWK scripts. So this will generate the sequence of numbers from 12 to up to 40 with the step of 4. And then inside of these curly brackets, we should write the changes which we want to change in this SCF and want to do the calculation. In SCF file, we actually want to change the value of E cut wave function. So here is the name list. Here is the variable whose value we want to change. And here is dollar sign. Here is the E. What does this mean? This means that dollar sign means the value of variable and E stand for the numbers from this sequence. The first
Okay.
sequence, the first value will be written here 12, second value will be 16, third value will be 20, and so on. It will go on doing the calculation. Also, then E cut RHO will be the 4 times the E cut wave function. So this is also written here because it should keep the uh, E cut row 4 times the E cut wave function. This is usually done in quantum espresso for norm conserving uh, pseudo potential. If there are pseudo potential, which are ultra soft pseudo potential, then it should be at least 8 times.
Okay.
After doing this, we will what the script do? It will run this command will tell it should run the SCF calculation, and this command will automatically extract the total energy from the files.
Okay. What
And
of the TiO, titanium oxide?
this is the name I have for the recognition that we are going to calculate the uh, uh, calculation for TiO. But for the present case, this is silicon. So I will change the name silicon here. so that I can recognize that these calculations were done for the silicon. And there was TIO because I have copied from this for the calculation of TIO to the calculation of silicon. So I would like to change it as SI silicon instead of TI. Is it okay?
Yes.
Then the output of the output of this command named as this command will extract the total energy from the PW output file. Uh, what does this mean? This means that so this means that from this output file, this command will extract this energy. Okay. And after extracting this energy will be written on a file whose name is ecot.dat. And write command is
Okay.
do all is all to write this write this file. Write command is used to write this file. And what is written in this file? In this file, first of all, this command will run the SEF calculation. This SEF calculation will automatically produce output files. And from each output file, this command will extract the total energy. And this extracted total energy will be written on in this file, and it is stored to the PWT by the side file. And after doing for 12, 16, 20, 24, 28, 32, and up to 40, all after doing all these calculations, each energy values and corresponding value of E got W will be written here in this file. And after writing this file, the this loop will end. After ending this loop, here is the plotting command. It will use uh, GNU plot to plot the E cut versus total energy. So we will be there with some result.
Okay.
Now you should ask some question, and then I will like to run the calculation. And want to
No,
show you.
actually, I have followed all what you did, and actually, I have to even watch the video before question arises. I have to watch the video and practice first.
Okay, let me run it.
So,
So
okay.
in order to run it, I just will let me see what should. One thing is
Now,
that I have also tell the code where should I write the out PIR, where I should write the
sai
out
kai ɗazu da kai muke ta magana.
PIR, because the calculation was run
Okay.
will run in this folder. The out DR will be written here, but I don't want to write out DR here. I want to write the out PIR here. So
Okay.
I have to make changes in this PWTK. So this out DR is in control. So I have to uh, some changes about the control. So I write here control name list, control name list, then double quotes. Then what I want to change? I want to change out PIR is equal to single quote dot slash out PIL and then single quotes and then double quotes.
Okay, are you done? Wait, okay, are you done with everything?
Yeah,
Please go back to the script PWE code PWTK script.
I also have,
Go back.
okay, let me tell you. I have also changed to the path of pseudo potential here. So again,
Okay. Go back to the
I PWTK and then I have to make some changes, another change, and for this change I will write his comma and I will write copy here, sorry, here, but I have to tell the code that where is the pseudo potential folder. So the I have told the code that pseudo potential folder is, and this double dot means parent directory. This means that the directory in which
okay.
this directory is present. And then I should, now you can ask what you are saying.
Okay. You okay, please. Are you done with everything? Are you done with everything? I want to screenshot it. I want to take a screenshot.
For this,
Yes, I want to screenshot it with my computer.
I would send it this file to you.
Okay, but let me screenshot first, please. Just 1 minute.
Okay, okay, take it. But I think this
Okay, I have
concept
screen.
would not be easy to understand. I will send this file to you.
Okay,
Now, every according to my understanding, everything is okay. Now, if we go to this folder and I open the terminal in this folder, and after opening the terminal, I will just write pwpk and then name of the file I want to run. So it is running.
okay,
Yes, it is plotted now. And this shows that when we increase the number of plane waves, the energy goes on decreasing. But
okay.
it seems that after 35 or 40, there it would become almost constant. Suppose
Yes.
I want to see that I want more. For example, I want to see what happens if we uh, do it for 60 or 70, up to 60 or 70. Let me show you how this is possible. We will close it. I will just open the PWTK and I will change it to 60. But before
Okay.
doing such changes, if we run the calculation, it will again start uh, from the uh,
12.
12, but I don't want to do it should start from the 12, it should start from after 40. And it should not do the calculation which those calculations which have already done. So in that case, I have to just write here restart true. Now it will not do the calculation again. It will do only those calculations which have not already done. For example,
Okay.
I will Again, it will say that this job is already done and next jobs it will do. Now, now see that as we have guessed that after 35 or 40, it will not change. So what does this mean? This means that we should use 40 or 45 the EGOT wave function because
Yes.
after 35 or 40 uh, total energy does not depend upon. So this is the convergence test with respect to variable EGOT WFC. Okay.
Yes.
If I will again run the calculation, it will say that all the calculation I have done already. So here is the plot. So what does this mean? This means that uh, from this convergence test, we see that we should use the value of 35 or 40.
45 upward.
Yes. Now, this is the convergence test with respect to E-cut wave function. Now we want to run the convergence test with respect to K points.
Points.
Then what will we do? Let me show you. Again, I will go to some where I have this file. I will just copy and paste. But before pasting here, I should calculate. I should create some folder because if I would not do the calculation in folder, then all these files would be written uh, here, and this after that we would not be able to recognize what are our actual file or what are used by PWTK to find run the
Okay.
conversion test. Again, we have to make some changes according to our needs. The changes should be again just as we have done for the EGUT. So I should, it would be easy for me to calculate. For example, I should use these two variables again in this case. So because I want to change also these regions here. So also something to change is to write this because our input name of the present case is in this folder and name is scf.item.
Yes, you have got
So I change the set the code that it should load from this. Also, for the present case, I will also write here restart true. Either you can say on or you can write true. Both will work. So what this script will do, first of all, it will load the input file from there and then it generate a sequence with 2 and 2 up to 10. What is meant by with the two-step up to and then it will change the out PIR and then will it find the path past flow potentials and then it will change the K points. It will first value of if this sequence is 2, so it will be 2 cross 2 cross 2 and this one means the uh, key point sorry, K mesh should be shifted. And
Okay.
then this is again run the command, this again extract the total energy, and all everything will be written in and here. And after doing the
Okay.
will
Then
go
you change the titanium oxide to silicon.
okay.
Yes.
Okay. Now I think everything is in contact intact, so I should run it and see what would happen. For that, in order to run there, we go in folder, open the terminal in this folder, and then again we just do the and then write the name of the file. So it is running now. Do you want to ask some question?
No, actually, I have to watch the video, but I've understand all your steps that you did for this calculation now.
And it says that if you can write the k point 4 by 4 by 4 or even after all those values, it will become independent of k mesh. So we can easily use either k mesh of 4 cross 4 or 5 5 or 6 6 6 or 7 7 and like that. It will not affect the total energy calculation. So this is the convergence test with respect to k points.
Yes.
Okay.
Yes.
So what will be changed in here is already 4 4 by 4 by 4. So we
Yes.
should not change it. So these are the convergence tests with respect to E-cut wave function and also with respect to uh, K point. There are other convergence tests. For example, we can find the convergence with respect to smearing, with respect to value of the smearing, etc. Because the value of smearing also affects the total energy calculation. So it makes sense that we should also uh, find the smearing value uh, for the calculation which would not affect the subsequent calculation within that smearing time.
Okay.
Now, if you want to ask me something,
No, I've understand it.
uh,
So because I notice you are feeling sleepy.
yes, you can say.